Hello everybody, my name is Govind and I'm here to show you how to use debugger to debug programs written in C. So what we'll be doing today is compiling a small program which I'm going to call Hello Debugger, and we're going to be compiling this into executable, loading this up into a debugger, and then we're going to be seeing some of the basic features of a debugger. Okay, so before we go into debugging the program, I'm going to be talking a little bit about why a debugger. So most of the times the debugger comes up in a context of like debugging programs. You have a bug and you want to be able to debug what the program does. That's when people recommend you to use a debugger. I would say that the debugger is a great tool to not just like debug problems, but also explore how a computer works or how your native programs work. So for this video, I'm going to be using the LLDB Debugger, which is part of the LLVM project. As you know, LLVM is project. It consists of like, it's a framework, it's a compiler infrastructure which comes with like a C++ library, compilers and other stuff. It's done by the famous Chris Latner, who is right now building Mojo. Okay. So LLDB is the debugger that comes with LLVM, and because LLVM is installed by default on Mac, I've just started with LLDB. You could also use GDB. The commands are a little different. I find LLDB's commands a little bit easier to understand and then like keep in my head, but essentially they're both the same. So let's start. Okay, so as you can see, this is my small program. What I'll be doing is I will be showing you how to load this program under LLDB, and then we can set some breakpoints, see how the program changes, and what the next steps could be. Okay, so let me start by compiling the program. So I just do c debugger.c, and then I turn this into a debugger. Now, here's an important part where I pass a flag called -g. What -g instructs is it instructs GCC to generate debug symbols. The debug symbols is pretty important for the debugger to know like what code is running in your binary. We will see the difference a bit later, what happens when you don't set this flag. So I set this, say LLDB, I connect the file, hello debugger, and I say the main, so it sets a breakpoint at the main function. So what happens is as soon as your code enters the main function, it stops, and then you can like look around and inspect the program. So I say run. As you can see, that we've set a breakpoint at main, and as soon as we enter main, like it stops. So main consists of calling just like one function called run a pointless loop, and let's see what we can do. So for example, if I want to know if there are like any local variables in the function main, I can do frame variable. We don't have any variables, so it just shows nothing. Now let's see something more interesting. So I say, okay, break run a pointless loop. It says another breakpoint, and I say continue, and it stops here. So you can see that there's a local variable I, and then there's a variable until, which we pass as a parameter. And what it does is it loops till it hits like until -1, and then it prints the statement that says we're about to exit the loop. And let's say a source list. This shows, for example, the full code of the actual. It shows the code of what you've actually written for those from the source. So what it does is like it shows like we're about to exit the loop, and then after it exits the loop, it prints like we have exited the loop. So let's use frame variable here. You can see, for example, that we passed in like a value as input until, and that's shown here. And there's like a local variable I. It hasn't started like running through the loop initialization yet, so you can see that the value is like a junk value. This is why it's important to initialize local variables properly in C, because if you don't, then you might have some junk values. Let's just step. I'm going to say step E, which steps through instruction by instruction. You can see that it just executes the first instruction, which is setting I to 0. So be a bit careful here, because when I say step I, it doesn't mean like execute one of the steps here. It means execute like a assembly instruction. And in most computers, like setting the value of a normal variable is just like one instruction. So just, like you can see that I is incremented after we do step E. Okay, so what else can I do? Then I can say, I think we can also have like, you can say thread step over, think. Just steps through the code, and you can see that it's stepping through each of the execution of the loop. So I use 1, so it's step over, step over, step over, variable. So you can see that I is getting incremented, and this keeps continuing. So then I can say thread step out. I think this steps out of executing the function in which it is currently in, and I can say continue, and this exits. So your debugger is not just for debugging programs, but you can also use it to understand how a program works. Like in future videos, I'll show you like more specific features. For example, you can set something called as a watch point, which when you set it on a variable, the program, and say, okay, like I set a watch point on X such that when the value of X changes to something like 5, then you stop the program. So you can see that in the future that this will be useful for like debugging, or like to understand like how your program is behaving. Okay, so now we can just exit the debugger. And so before this I was talking about this symbol, the -G. So you can see that it creates on Mac at least a folder called dsym. That's where all of the that's where all of the symbols that it needs for debugging a program is present. So I think I can do hello debugger. You can see contents. There's like dwarf symbols. It's like a non-human readable file, but that's fine. Like we don't care about it too much. What happens if I remove this file? So let's say I can remove this file, this directory. Debugger.dsym, LLDB file, debugger. Okay, let's say vmain, run. You can see that previously you saw that we were stepping through like source code, but now it's just showing assembly instructions, and main variable won't work because it says like it cannot find any debug related information to it. So yes, the flag is important because it creates the debug symbols, and then your LLDB on Mac uses this folder to the debug symbols to understand like what part of the source code corresponds to what part of the executable. So yes, this is a short intro to LLDB. There are obviously more features, but which we will cover in the next few upcoming videos. Thanks for watching, and have a great day.